Welcome to revision week 15. This week we are revising character sets and sound, which is part of paper 1. So make sure you've got your sheet 15 ready to go and a pen and paper to fill in the answers. Okay, let's have a look at character sets. So we've talked about how computers store things using binary numbers. We've gone over binary numbering systems 1, 2, 4, 8, 16, 32, etc. and hexadecimal. So now we are thinking about how do characters, things like letters, symbols and words, get stored in binary? Well, binary can be used to represent those characters. Any alphanumeric character on the keyboard, lowercase, uppercase, symbols, letters, numbers and things can be represented as a binary number. They can't process them directly, so they have to be stored as binary in some format. For example, capital A can be stored as 100001, lowercase k could be etc. Okay? A whole set of these characters and their binary numbers, binary values, is called a character set. So a character set is a collection of characters and their binary representations, the binary numbers that represent those characters. There are different character sets that exist, however there's only two that you need to know for the exam, and that is ASCII and Unicode. And you can see an example here of the ASCII character set with all the different characters that it represents and the binary numbers there, and their denary equivalent values as well. So what happens when you press a key on the keyboard? A signal is sent to the computer as an electronic signal. That signal is then converted into a binary number, a binary code, and that number is looked up in the character set. It finds the character and then outputs that character onto the screen. And that happens in an instant, really quickly. But it's the character set that's used to look up the binary numbers. So, two character sets. The first one we looked at was ASCII. It's the most common character set in the English-speaking world. Every character in ASCII is represented by an 8-bit binary code. For example, L would be 01001100, and you can see it there, capital L. There's also a lowercase l with a different value. In ASCII, you can store a maximum of 256 different characters in total, which is enough for all the English letters, numbers, and basic symbols. So, an advantage, it supports English ones and also some European languages, like the characters used in Spanish and French and things. And it only uses 8 bits to store each character. However, disadvantage, it does not support languages with completely different alphabets, like Chinese and other things like that. Only basic European languages. The other character set we learnt about. Let's just go through that. So ASCII is fine for English-speaking countries and some European countries like French and Spain. However, there's only space for 256 characters. What about storing languages with completely different characters? Or even emojis, for example? Well, what is the solution? We need a character set that can store more characters, and that character set is called Unicode. That is one solution. In Unicode, there is a lot more space for storing way many different characters, even emojis and things such as Braille characters and things like that. So what is Unicode? Unicode is another character set that uses up to 32 bits per character. So every character is stored as either 16-bit or 32-bit code. So a lot more bits for each character. This allows for over 65,000 different characters to be stored, which is way, way, way more than ASCII. So, advantage is enough space to store all the possible characters and major languages in the world, even space for emojis. However, the disadvantage is it takes up a lot more space to store because there are much more bits used for each character. On your sheet, complete this section now please. Pause the video. What is a character set? Key features of ASCII, key features of Unicode. Do this now, please. Okay, time to check your answers. So what is a character set again? A collection of characters and their binary representations or their binary values. And we've got ASCII, 8 bits per character, 256 different characters. Enough space to store all the characters in European languages, and only uses 8 bits, but doesn't support all the languages in the world or doesn't include symbols. Unicode, 16 or 32 bits per character, over 65,000. It supports all major languages, including ones with completely different alphabets, but disadvantage requires more binary data to store text, takes up more storage space. Checking your answers, adding if needed. Okay, we've looked at character sets. Let's also look today at sound. Sound is another thing that has to be stored on the computer, but cannot be stored in the same way as it normally does. Normally sound travels as analog waves that go up and down, and you've got an amplitude of the wave depending on the sound that's being recorded. Amplitude, the height of the wave. Now, to store on a computer, this wave has to be sampled. So sampling is the process of taking measurements of the wave as it goes along and turning it into a binary number that can be stored depending on the height, the amplitude of the wave. So sampling is the process of converting sound from analog, the wave, to digital, ones and zeros, binary, by measuring the amplitude or the height of the wave at regular intervals, regular points in time, every 0.1 of a second, for example, and recording this as a binary number, just like in the example you've got here. Other things you need to know: the interval is the gap between each sample. Could be 5 milliseconds, could be 10 milliseconds, could be 1 millisecond. The gap between each sample is taken. The sampling frequency is the number of samples that are taken per second. So the more samples you take per second, the more like the original sound it's going to be like. However, the more binary data and more space will be needed to save the data. So the number of samples taken per second. As well as how often you sample a wave, another factor is how much detail you take about each sample. If I only record 2 bits per sample, I'm only going to get a very rough reading. However, if I take 8 bits of detail per sample, I'm going to have a lot more detail about that sample. So a lot more detail would mean it's better and closer to the original, but obviously then there's more binary numbers to be stored. So sample size, or sample depth as it can be referred to, is the number of bits available and used for each sample. In this example here, look, I've got 3 bits that are used for each sample. Each sample, 3 bits of data are stored. The more bits you have, the better the quality, the more sound levels that can be stored, from rubbish down to awesome, but also the larger the file size as well. And finally, last bit, put it all together. To measure the amount of bits that are used per second, we use something called the bit rate, the number of bits used per second. And this calculation is important. You may have to work it out in the exam. The bit rate is the frequency multiplied by the sample size. The last 2 numbers multiplied together. The number of samples per second multiplied by the number of bits for each sample, which will give you how many bits are used per second. So on your sheet, complete this section here, look at the example waves you've been given and answer the questions. Do this now, please. Okay, hopefully you've paused. Time to check your answers. Let's go through this. Check and correct if necessary. Sampling is the process of converting sound from analog to digital by measuring the amplitude, the height of the wave, at regular intervals, points in time, and storing the reading as binary numbers. Looking at this wave here, what is the bit depth? Well, if you look on the left-hand side, you can see, look, there's 4 bits for each level. So 4 bits of data is used. What is the frequency? So along here, for 1 second, if you count them up, there's 10 samples per second. So frequency is 10 samples per second. And these ones here, sample interval, the gaps between each sample is taken, sample size, the number of bits available for each sample, frequency, the number of samples taken per second, and to work at the bit rate, it's the sampling frequency times the sample size or sample depth. Ticking, correcting with your purple pen, making sure you've got the right answers. Okay, final things today. As always, go to LearnConvene, revision quiz 15, make sure you check each question and try again if needed. You are aiming for 100% by the end. Good luck, see you in lesson.